All right, hey everyone, on to day 3. So the first two sections of 8.3 were on the number e and how we can graph it. Today we're going to talk about how the number e is used in exponential growth. So we will start with the equation that uses e. The equation is PERT, a equals p times e to the RT power. And I'm going to add in here a little times symbol because it's r times t. Okay, the a is the balance. This could be the balance after 5 years, 10 years. It's just where your account is at. The p is the initial amount. The r is the interest rate. And this is always percent changed into a decimal. Okay, it's going to be given as a percent. You want to change it to a decimal. And then t is the time in years. Okay, one thing I want you to know is that this equation is different from other ones. Our other compound interest equation was when it was compounded monthly or quarterly or semi-annually. E is used when it's compounded continuously. Continuously is when we use E. Right, so we have a couple examples. Just before we go on these two, know that this is the most common one when you actually put money in a bank or when you take out a loan. Money usually is continuously growing. So like when you take out a college loan, that money grows year by year, month by month, day by day, like within the hour it might go up so many cents. So that's why it's continuous growth. All right, so example 1. If Algebra deposited $1,500 in an account that pays 5.25% annual interest and it's compounded continuously. Continuously means we have to use E. And we want to find the balance after 3 years. So we know the equation is A equals P times E to the RT power. Okay, we know that because it says continuously. Over here, the principal I'm going to list is $1,500. The rate is 0.0525. Again, because we have to change this percent into a decimal. And then the time is equal to 3. And the balance is what we're trying to find. We don't know what A is. So now we take our equation and we substitute in these values. So A equals 1,500 times E to the 0.0525 times 3 power. And when you use your calculator, you're going to want the parentheses to be around those two numbers. Okay, so when you use that the computer calculator, that's the easiest one I think for this. You're going to put parentheses around the R and the T. And when you type this in, you should get $1,755.87. So after 3 years, it went up by about $255. Okay. And then on to our last example. Geometry deposits $2,250 into an account that pays 3% annual interest that is compounded continuously. Continuously tells us we use E. And we want to find the balance after 7 years. So again, we know we're using the equation that has E in it. So PERT, P times e to the RT power. Off to the side, we have P is $2,250. The rate is 3%, so it's 0.03. And this time, the time is 7 years. And we want to find out what is the balance. So we go in here. If we don't know A, so we're going to plug in for everything else. So you plug in your calculator just like this, 2,250 times e to the 0.03 times 7, parentheses around the 0.03 times 7. And we should get $2,775.76. So this one made about $525 in 7 years. So that's how continuous interest works. That is what your banks will do. Any loan you take out for college, this is kind of how that's going to grow.